over just to record it. So all of the classes in the quick reference are available. There's the quick reference in the chat. There's a link to it in the information about the exam. You don't have to worry about methods being passed in invalid parameters. So like is leap year is not going to get called with a null value or a string value or something. It will be an integer. You should use the methods in the question. Don't try and rewrite them. You won't have time, first of all, and second of all, you get points for using the methods that exist. So you will not get points if you don't use them. So here is a class called AP Calendar. And the first method in it is leap year. And you can see that it is a Boolean. So it returns true or false. And it takes an integer parameter called year. So if you pass in the year 2004, it will return true. They don't show you the implementation. This is really, really common in the AP questions because you don't care how they decide whether it's a leap year or not. That is not relevant to this question. You won't get or lose any points if you know how they do that. You can just assume that some magic happens here where when you pass in an integer, it correctly tells you true or false whether it is a leap year. The next method is number of leap years, and that returns the number of leap years between year 1 and year 2 inclusive. So if you are taking the paper version of this test, I would bring a highlighter, or maybe you're only allowed a pencil, but I would circle that word inclusive because that is important, right? Whenever you have the word between, you need to know whether it includes the endpoints or not. So precondition, this is something that will always be true. 0 will be less than or equal to year 1, will be less than or equal to year 2. So you know that both years are greater than or equal to 0 and that year 2 is greater than or equal to year 1. So you don't have to worry about negative numbers, basically, is what they're telling you with this. So if, for example, you pass in 2003 and 2005, it will return an integer, or should return an integer, 1. If you pass in 2004 and 2008, it should return 2 because it's inclusive. And this is the first thing that you are going to implement, right? So again, don't worry about it for now. You'll be implementing it later. You just need to understand what's going on. The next one, first day of the year, returns the value representing the day of the week for the first day of the year, where 0 denotes Sunday, 1 denotes Monday, and 6 denotes Saturday. So for example, let's see, calendar. The first day of the year this year was a Friday. January 1st, 2021 was a Friday. So if you put in 2021, it would return the number 5. And again, implementation not shown, which means you're not going to have to write it. You can just assume that they have perfectly coded their implementation in the background to do exactly what they said it's going to do. Day of year. So this again is going to return an integer. It's going to return that integer where month, day, and year specify the nth day of any year. Okay. So, for example, if you give it January, so January is 1. Okay. So 1/1, right? Month 1, day 1 of any year, pretty much. But if you have to pass in some kind of year, it will return the number 1 because that's the first day of the year. So today, today is the 55th day of 2021. So if you passed in February, so 2, sorry, if you passed in the number 2, the number 26, and the number 2021, it would return 55. You don't care how it does it, you just know that it does it. So you'll probably have to use this later on. All right, last one. Day of week returns the value representing the day of the week for the given date, month, day, year, where 0 denotes Sunday, blah, blah, blah. The date represented by month, day, year is a valid date. So this is similar to before, but this time you're given a specific month, a specific day, and a specific year. So, for example, if you passed in month 2, day 26, year 2021, it should return Friday, which is 5. Because today is Friday. And again, looks like you're going to implement this in Part B. And it says there may be other stuff not shown that you can pretty much ignore. So Part A says, write the method number of leap years, which returns the number of leap years between year 1 and year 2. You know you have is leap year. And you know that the years are incremental. You don't have to deal with negative numbers. So you have to use is leap year to receive full credit. So if you tried to write a method that figures out whether it's a leap year or not, you would not get full credit. You have to use their version. And then in here, you literally have to type your answer. Right? So you would start, you can either start with that, or you can probably just start with that because they have already put the header up there. And then you have to type your code in here to figure that out. So take a minute right now. Think about for loops, while loops, these numbers, where you would start, where you would stop. And this method is leap year. So don't type anything in the chat or say anything out loud yet. But I'll give you a minute just to see if you can think in your mind what you would do to fill in this method right here. So I'll give you a minute or so to think about it. All right, so I want you to type in the chat, just in like Englishy pseudocode. I'm not worried about specific like Java constructs, just kind of Englishy pseudocode, what your is leap year would look like. Don't hit enter yet. Just type it in the chat, but don't hit enter. I'll ask you to hit enter all at the same time. So in the chat, how would you write is leap year? It can just be in English, given year 1 and year 2. It can be in Java, it can be however you want to do it. I just want you to think about how you would write this. It's okay if you're not 100% sure on the syntax for for loops and stuff like that is what I'm getting at. All right, you ready to hit enter? And go. Okay, so a few people answered. Are the other people, anybody still typing, or are you just not sure how to approach it? You can just say it aloud. Okay. So we got some good ideas here. One thing that I want to point out with Tony's answer is and sorry to single you out, but this is exactly, this is important to know. So it's really common, so don't feel bad, Tony. I just want everybody to know that if you try to calculate whether it's a leap year yourself, you're going to lose points, right? Specifically, it says you must use is leap year, right? So again, on the exam, I would circle that or highlight it or do something, because you have to use is leap year. So if you use mod 4 and look for 0, you're going to lose points. Also because you would have to do 100 mod 0 to make it not a leap year, and then 1,000 mod 0 to make it a leap year again, because leap years are weird. All right, so Peter had a good idea. Arhan had a good idea. The one thing is, remember what I said about the difference between while loops and for loops, right? When do you use a while loop and when do you use a for loop? Generally speaking, you use a while loop when you don't know how long or how many repetitions you have to get to the end, right? You don't know how many guesses the user needs to guess the secret number or the password or whatever. You use a for loop when you know exactly how many times you need to do something. So in this case, right, we know exactly how many times we're going to do this. We're going to start at year 1. We're going to stop after year 2. That's one of the keys here. So we know exactly what our starting condition is, our stopping condition, and our increment, which is going to be 1. So yes, you could use a while loop, because you could say, while my counter, start my counter at year 1, while my counter is less than or equal to year 2, inside the while loop, you increment the counter by 1. But that is exactly what for loops were created for, right? If you look at Peter's example in the chat, it's not quite syntactically correct, but the idea is right, right? He has a counter I. He starts it at year 1. It stops when it's no longer less than or equal to year 2. So notice that it's less than or equal to, because remember the question asked for inclusive. So the start, for loops always have a start, a stop, and an increment. Oh, you guys can't see me highlighting this. Let me put it in here. So here we go. So this was Peter's answer in the chat. So year 1 is where we start. Less than, we keep going as long as it's less than or equal to year 2. And we add 1 each time through the loop. That's how for loops work. Start, condition, end. Start, condition, increment. If is leap year, right? He used the is leap year. Then he has some variable called leap years or number of leap years. He adds 1 to it. So I'm going to go ahead and flesh this out a little bit more. I'm going to say int num leap years equals 0. Right? Because if they give us the same 2 years, year 1 and year 2 are both 2021, right? There are no leap years in there. Or int I equals year 1, I is less than or equal to year 2, add 1 each time through the loop. If I is a leap year, right? It's going to return true if it's a leap year. We know that from above. Leap years plus plus. And then once we're done going through all of those years, we need to return num leap years. So this answer would get you 5 points on this question. It'd get you full marks because you return an integer that is the number of leap years between year 1 and year 2 inclusive, and you appropriately use the method is leap year. So in the chat, give me a plus minus squiggly for understanding Not only the answer to the question, but like how you could work out the answer to the question. Again, I recommend the first thing you do on the exam is type out your answer in English-ish, Java-ishy, English-y, right? Try to figure out the algorithm in your mind. Don't try and immediately do it in Java, because then your brain is like spending half its effort worried about Java syntax instead of worrying about the algorithm. So if I were answering this question, the first thing I would do actually is I would type right in here, I would say, go through the years from year 1 up to and including year 2, right? And then I'd say if is leap year current year, then add 1 to leap year counter, and then at the end I know I have to return leap year counter. That is literally what I would do if I were solving this problem. I would start with that and then be like, okay, does this work? Go through an example. 2003, 2005. 2003, not a leap year. 2004 is a leap year. Add 1 to leap year counter. 2005, not a leap year. We exit that loop, we return 1. Okay, I'm pretty confident in this algorithm. Now I'm going to try and convert it into Java code. Because even if you submit this, you'll get a point or two. Because here's a point. I have used is leap year appropriately. Here's a point. I'm returning a leap year counter. Right? 2 out of 5 is not bad for this. Right? It shows that you understand what's going on. So starting with something like this is always, always, always a good idea. All right, so part B, I don't think we're going to go through the whole thing. Well, let's take a look at it. Write the static method day of week, which returns the integer value representing the day of the week for month, day, year. Okay, so day of week, January 5th, 2019, returns 6 because January 5th, 2019 was a Saturday. So in order to calculate this value, we have first day of year, and we have day of year. So I'm starting in my mind to already think about how this is going to work. Because they already give us the day of the year and what the first day of the year was. So I'm thinking in my mind, right, if it's January 14th, and I know that the first day of and I know that the first day of January was a Friday, then the 14th will be a Thursday, right? Or let's say the 15th will also be a Friday because that's 2 weeks later. The 22nd will be a Friday. The 29th will be a Friday. So how do I do that mathematically though? Right? That's kind of the question. So I have is leap year, number of leap years, first day of year, day of week. And I need to do day of week. Okay. So I'm thinking here, first get the day of year. Day of year equals day of year, and I pass in exactly what they gave me. Right? So this is going to be something like, I don't know, 120 or 55. We'll go with today. So I know that today is the 55th day of the year. I need to know first day of the year, first day of the week. No, first day of the year. Of the year is what it's called. First day of the year. I'm going to need to store that for whatever year they pass in. So for 2021, the first day was a Friday, so that's going to be 5. So how do I figure out that today is also a Friday? I'm a little bit confused on whether I need to use leap year. I don't think I care, because I feel like the day of the year will take into account whether it's a leap year or not already. So I'm not going to worry about that for now. Because it says day of year here, this method accounts for whether it's a leap year. So I don't need to worry about that. So I'm not going to worry about leap years. I'm just going to say if today's day 55 and the first day was a 5, then I'm going to need to do something mod 7 here. I feel like I need to either divide by 7, I'm going to need to mod by 7. So I'm going to give you guys 30 seconds to think about this too. And I'm going to think about it. I'm going to try and figure out, I'm going to shut up for a little bit, and you guys see if you can figure out, how can I know what number day of the week from 0 to 6 it is, if I know that today is the 55th day of the year and the first day of the year was a Thursday or 5. See if you can figure it out on your own first, and then I'm going to figure it out loud. Oh, it's 57. Sorry. I was wondering why I didn't. Why did that other one say 55? Weird. I'm just high. So today is the 57th day of the year, not the 55th. All right, so I have an idea on how to do this now. Does anybody want to explain their idea on how to do this?
I don't think this works all the time. Like, I was just thinking 57 mod 7, and then you get that result. And then you can add that to, I think you can add that to 5. Oh, wait.
No, that's a great start. That's an absolutely good start. So if we take the day of year and we mod it with 7, right? What does that give us? So that gives us like the offset from the first day of the year, right? So if we get, it's kind of in theory, if it were 2, that means we are 2 days ahead of the first day of the year, right? So if it were, you know, if today is 57, then 57 mod 7 should give us the offset. How many, like if it were exactly 56, right? Then it would, like intuitively, it would be that if you mod 7 and get 0, it should be the same day of the week as whatever it was on New Year's Day, right? But, and this is where computer science gets tricky, the year doesn't start on day 0. Right? If the year started on day 0, that would be true. But it doesn't. It starts on day 1. So if you look at a calendar, if you look at the days where dividing by 7 gives you a remainder of 0, they're 1 day back from Friday. If only the calendar started at 0, Zoe would be 100% correct, because 0 would be like December 31st, for example, and then January 7th is the same day as that, day of the week. The 14th would be the same day of the week. The 21st would be the same day of the week. The 28th would be the same day of the week. But because we start at 1, we have to subtract 1 from our current day, or however you want to think about it. There's an off by 1 error there. The days of the year divided by 7 will always give us the answer 1 for the same day of the week as January 1st, right? So look at the example in the calendar here. The day of the week for January 1st was Friday. The next Friday is the 8th of January. So 8 divided by 7 gives you a remainder of 1. 15 divided by 7 gives you a remainder of 1. 22 divided by 7 gives you a remainder of 1. Right? 57 today divided by 7 gives you a remainder of 1, because it's the same day of the week as January 1st. So any day of the year here that gives you a remainder of 1 is the same day as the first day of the year. So this is one of the tricky things about this question, is the conversion between a calendar that starts at 1 and computer science and math, which starts at 0. So again, I'm going to write this down in here because it's important. Actually, I'll write it down here. Any day that has a remainder of 1 is the same day of the week as the first day of the year. So what I'm going to do is I'm going to say offset equals the day of the year, the remainder of that in 7, minus 1. But I'm not done yet, because what happens if the day is 61? All right, so 61 mod 7 is 5. If it's the 61st day of the year, then it's going to give me an offset of 4, because I said day of the year mod 7 minus 1. But 5 plus 4 is 9. That's bigger than the days of the week I'm allowed excuse me, to have. So I'm going to have to wrap it around again. And I'm going to have to say day of the week to return is first day of the year plus the offset again modulus 7. So that if the first day of the year is like a Friday and I'm sitting at Tuesday next week, I don't accidentally return the number 10, which is not a valid day of the week. I have to do 10% 7, right? Which would be 3, which would be Sunday, Monday, Tuesday, Wednesday, whatever.
Mr. Bartus, we still see the Google calculator.
Oh, sorry. Thanks. So the offset is the current day of the year modulus 7. So the remainder of that was 7 minus 1, because we started, remember, the first day of the year starts at 1 and not 0. And then we still have to take that whole thing, add it to whatever the marker for the first day of the year was and take the remainder of that with 7 again, because it might be Friday plus 3 days. And we have to wrap around, just like weeks wrap around, Friday, Saturday, Sunday, Monday, Tuesday, Wednesday. We have to return the number 3, not the number 10. Because the number 10 is not a valid day of the week. So let's convert this into actual code. I'm going to say, I know this is going to be an integer day of the year, and I can call it the same thing, or I can just call it DOY, day of the year, equals the day of the year for the month in. And these variables right here, I just got from up here. It's whatever they sent to me, I'm passing it into the day of the year. I'm going to call this first equals the first day of the year. I'm going to call this offset. And then I'm just going to return whatever the first day of the year was, plus the offset, modulus 7, to give me the actual weekday. So again, even if you miss this -1, don't worry about it. Even if you miss this %7, don't worry about it, right? Write down in Englishy, Java-ishy English, your algorithm first, and you will get at least a couple points for it, even if it's not perfect, right? These are supposed to be tricky, hard questions. You are not supposed to get perfect on all of them unless you are like an awesome super programmer. It's okay to submit pseudocode. So my strong advice to you is to do what we just did, which is go through it line by line, make sure you understand what they're asking. Make sure you understand when they say you must use a certain method. Go ahead and, write it in pseudocode first. And then if you feel confident right away, go ahead and convert it to Java. If you don't, move on and do the next question and come back to it later. Right? As long as you put something down that kind of solves the problem, you'll get some points. And that is the name of the game on standardized tests, is getting as many points as you can. It's not about getting it perfect. I know this is programming and computers are very picky about this stuff, but honestly, on the AP exam, they're more interested in, do you understand how to make the algorithm work, than whether you got your semicolons right. So even if you don't 100% understand why this works, if you understand how I kind of worked through the problem in my mind and how I came up with the ideas to solve it, that's enough. That's okay. You can come back when you've finished other problems and say, all right, I'm going to work through this with a pencil and paper now and see and try different examples. Try Fridays and Mondays, try the edge cases, try all sorts of different examples and see if it works. And then I can try and fix it. But as long as you get a general idea and you say, I'm using these methods they told me to use, you'll get points. And that's the name of the game. So for the AP exam, if you get above 80%, that's a 5. That's a perfect. So they're not expecting you to do all these questions perfectly. And I know AP students tend to really want to get perfect on everything, but I'm telling you right now, it's okay to not get perfect on these. All right. Are there any questions about how this second algorithm works? Whether it works, why we need the -1 or this other %7 or anything like that? Okay. So give me a plus. Can you do day of year -1 first? 10%7, sure. So let me bring up the calendar again, because I think that was the best way to explain the -1. Here one. There we go. Okay, so what we're really looking for when we say the offset from the first day of the year, what we really want to know in this question is how many weeks are we? Right? Because when we're trying to figure out the day of the week, if the first day of the year is a Friday and August 13th is also a Friday, what we're really trying to figure out is it exactly a multiple of 7 days between August 13th and January 1st? And when you're trying to figure out multiples, you use modulus, right? So think about modulus 10. If I want to know if something is a multiple of 10, in Java, I say, give me that number, modulus 10, and that will tell me the remainder of dividing by 10. If the remainder of dividing by 10 is 0, then it must be a multiple of 10, right? 100 modulus 10 is 0. There's no remainder when I divide by 100 by 10. And so with weeks, we have to use 7, right? That might be a better way to think about it. So if I take 22 modulus 7, I'm going to get 1. I'm going to get a remainder of 1, even though it's the same day of the week as Friday. All the same days of the week as the first day will have a remainder of 1. So maybe the best way to think about this is not to subtract 1 afterwards, but to actually, oh my God, I'm showing the wrong tab again. So all of these modulus 7 are going to have a remainder of 1. All of them, all the Fridays this entire year, if this is like the 200th day of the year, then when I do it modulus 7, it's going to give me a remainder of 1 because it's a Friday. Every Friday this year, whatever that day of the year out of 365, whatever day that is, modulus 7 will always be 1. If calendars started at 0, then it would work fine. Then, then the first Friday would be 0. The next Friday would be 7, the next Friday would be 14 and 28 and so on, but it's not. We start at 1. So if I subtract 1 from the day of the year, that might be a better way to think about it. So maybe this is a better way to think about it. This will produce the same answer. All right, looking at January, the 22nd of January is the 22nd day of the year. If I subtract 1 from that, I get 21. 21 modulus 7 is 0, so I know it's the same day of the week as the first day of the year. So let's do an example in August, August 20th. August 20th, 2021, day of the year. What day of the year? Okay, so August 20th, 2021 is the 232nd day of the year. So we know it's a Friday. So what I want to do now is say 232 minus 1 mod 7 is 0. Because it is the same day as the first day of the year. Does that make sense, Zoe? Awesome. So then the other problem that we had, right, is this, the offset plus the first day of the year might be bigger than 7, right? And we're trying to return a number from 0 to 6 to represent the days of the week. So the first day of the year for 2021 is a 5 because it's Friday. When I'm calculating my offset, right? So let's try and figure out what, as an example, January 27th is, right? So we know that it's the 27th day of the year. So 27 minus 1 mod 7 is 5. So that's our offset from the first day of the year. Remember, if it's 0, it's a Friday. If it's 1, it's a Saturday. If it's 2, it's a Sunday. If it's 3, it's a Monday. If it's 4, it's a Tuesday. If it's 5, it's a Wednesday. Because it's how many steps beyond the first day of the week of the first day of the year do we have to go, right? That's what the offset from the first day. So if we go back to our code here, the first day of the year is a 5, and now our offset is also 5 to get to Wednesday, because we're adding 5 days from Friday to get to Wednesday. But we cannot return the number 10. That's not a valid weekday. It has to be between 0 and 6. And the way we get 0 to 6 is we take the remainder of dividing by 7. So to put all of our math into one line, we would take that plus our offset, which is 5, and then we would take that modulus 7 again. So if we did it without the modulus 7, right, all Wednesdays would be 10, and we can't return 10. We have to return 3. Because, wait a minute, is that right? I might have messed this up as well. 10 should be a Wednesday. Sunday is 0, Monday is 1, Tuesday is 2, Wednesday is 3. Nope, I got it right. So we can pick a different date here. Let's do Thursday in November. November 25th. What day of the year is November 25th, 2021? November 25th, 2021 is the 329th day of the year. I put it into my little calculator here. And if I did not do %7, then it would give me the number 11. There is no 11th day of the week, but there is a 4th day of the week. So Sunday is 0, Monday 1, Tuesday 2, Wednesday 3, Thursday is 4. So it gives me the right answer. All right, any other questions? I spent a lot of time on that, but I think it was worth it. Oh, crap doodles. You're right, the ACT is on Tuesday. All right, here's what I'm gonna do. I will post it on Tuesday and make it due on Friday. Is that fair? Okay. So I'm not gonna make you time it. Just so you know, the actual AP exam, you have an hour and a half to do, I think like, what is it? 2 of these with A and B sections. So there's like 4 total. Is that right? Should look it up. Here, I'll stop recording now.